Hi, and welcome to this video on how to do binary streams with a musical twist in Business Central. Hey, my name is Eric, and in one of the previous videos, I asked if people wanted to see an example of how to do a binary stream. We did stream with just text in that video, and a lot of you said, "Hey, show us how to do binary stream," and then that got me thinking, what kind of binary? Because it needs to be something that I can kind of show here in the video, and the go-to thing would be to create a photo, but that's kind of been done, unless it hasn't. And if that's what you want to see, subscribe to the channel and let me know in the comments. But so in this video, I'm going to create a wave file. So we are simply going to use Business Central to create sound. That probably qualifies as a hack, because I don't think anyone ever imagined an ERP system producing wave files. But here we go. So let's talk about what's a binary file. And this is the file format for a wave file. You can see there are three distinct chunks in the file. The first one is 12 bytes that we call the riff chunk, and it has a it's kind of header zone saying that this is this file, so programs can easily figure out if this is a WAV file or some other files. Then we have a format chunk that kind of describes the format of the audio to come, and then the data chunk, that's the data. So let's try to recreate this. The first thing we can do is we can see that some of these are 4 bytes and 2 bytes, and then, well, the chunk is depending on the chunk we put in here. Some of these are big endian and little endian. So different computer architectures stores data differently. And when dealing with binary, it's important that the file definition is clear on whether you're working with big endian or little endian. And I found this wonderful drawing. Let me show you. So a big endian machine says that if you have the Cafe Babe hexadecimal value, it will actually be stored as readable. If you have the little endian format, then it will be BABAFECA. So reverse. And just something that you need to keep in mind when working, that even though if you're on a big endian machine and you need to produce something, that binary needs to be read by a little endian machine, or if it's part of the file format, that's something you have to do. Typically, binary files that are living in the Intel x86 world will always use the same. So let's get back to this. Here is another way of looking at it. We can see that this is from a hex editor, and let's look at the first 12 bytes. And this one says, we can see when we look at it, it says riff and something not readable in a wave. And we can see here again. So the representation, let's actually grab the good old calculator and look at those hexadecimal. So we set this to hex and says 46465249. That's 1,179,030,705 in decimal. So in reality, what we can do is just take a integer variable. An integer in Business Central is 4 bytes, and put this value in and write that into the stream. So let's get into the good old Visual Studio Code. Here it is. Let's start from the beginning. So I have created a new file, and in order for this video not turn into me just typing, I've actually done most of it. So I'll explain what I have, and then we can finish this together. So I have created, well, there's quite a few lines of code, 155 lines of code here. And I have a function called generate, and the function called generate sets up a couple of constants. The samples is just how many samples do I want to represent one beat. I'll explain that a bit later. Then samples per second is the sample rate. So right now we're saying that the audio quality of what we're producing will be 44.1 kilohertz. Meaning that's the same sample rate as we have on a CD. So then I have a function called build scale. We saw it. I quickly scrolled past it. So build scale. So scale is actually, you can see that's a dictionary of text and decimals. So I created a scale with the different musical notes and their frequency. So starting at a C at 261 Hertz and ending at a B at 246.9 Hertz times 3. So this should not turn into a musical theory video. If you want that video, go somewhere else, because that's not Business Central. So there's better channels for that. Anyway, the only thing I want to say is that whenever you're whenever you are going an octave up, you're doubling the frequency, which actually means that this one is wrong and should be 4 here. So we build a scale. Then I have a code unit, a temp blob. So let's actually go back for 1 second here to this thing, because here's an interesting thing. So as you can see at the end of the file, we need to write the size of the data before we write the data. So that's a catch-22, because unless we know exactly how much data we're going to write, we're not able to write in the size of the data to come. So that's also something we need to consider. So music is a temp blob. And what is a temp blob? Temp blob is basically just a block of memory that you can put data into through a outstream, and you can take data out through an instream. And in this case, writer is an outstream. So I created a function called add tone. So write into this writer a musical note, and then the duration of that note as a fraction. So even though normal music is typically in whole, half, quarter, 8/16, and so on, this is very, very advanced music, because we are actually using a 1/9 of a beat. So anyway, that's a very, very musical joke. So after this function has written all the notes, we're going. I'll show you add note in a second. Then we're actually creating a new temp blob. So we had 2 temp blobs. The other one called wave. And into the wave, I'm just reusing the outstream. That's actually a bad practice, but let me know in the comments if you also do that. So I create a new outstream, and then I write the header into the outstream, and you can see now I can put the music length, because I wrote all the music into the music temp blob and have the length of that, so I can add that information to the header, and then if you saw the streams video, you know that copy stream is the pump. So now I can create a in stream from the music temp blob and copy everything from the music temp blob into my wave temp blob. And at the end, I create an in stream so I can read my wave temp blob, and then I pass that to download from stream, which has its own pump built in, so it will grab all the data in the wave temp blob and download it as sound.wave. Okay, so what happens in add tone? There's some musical math. Actually, before I do it, let me just do one thing, because if you remember this one, then it said that some of these are 2 bytes, and in Business Central we do not have a 2-byte data type. So in C and C# and everywhere else, we have the concept of, it's typically called a short. On some older platforms, the integer data type was actually 16-bit and long int were 32. So integer tend to default to the bit size of the platform. So in this case, you could also say that this is an int 16. So the 16 bits are represented. Anyway, we need to give a 16-bit value, but we don't have that in Business Central. So let's look at the header function for just a second. If you see here, so the actual writing the header is simply outstream.write. Remember, the .write is that there are 2 functions on there's 2 pumps on outstream.write that will write a binary, and write text that will write it as readable text. And write text is what we used in the last video, and write is what we're going to use in this case. So if we're writing a integer, we're actually just writing those 4 bytes that is the binary representation of that integer. So we're not writing 12 bytes or 10 bytes that shows the actual number. We're just writing those 4 binary bytes. And in this case, the ref, we know it has to spell out ref. And I took, if you remember, we talked about this value, unless I typed it wrong, because this is the value that I'm putting down. I may have typed that wrong, sorry. This is the right value, trust me. So this number 1.179011141 is the binary, is the integer representation. That binary will be written as ref in the file, and this will write as wave. And then we have the problem, going back to this, we have the problem with those 2 bytes. So audio format. So audio format, you can see that I have just set that to be a byte. So the problem with the 16 byte that we don't have anything between an 8-byte value and a 32. We're missing the 16. So what we're actually doing here is a hack, because the format should be a short, cannot be, but we know the representation is that we get it's 2 bytes, and in case that we only have, in this case, this is a hack, because format type is just 1, and we can represent 1 in just 8 bits. So we write that in, and then we add in what I call a null, meaning just a single 8-byte 0. So we fill out the 16 bits, which is very important, because otherwise it has, even though the value is the correct one with just 1 byte, it has to fit the placement. So we need to pad to get the right size of the header. And you can see there's a couple of other places I do that in the header. And then I can write in the data length, because at this point we have already generated the music we want, so we can put the data length into the header. Okay, so back to the add node. So the beginning of this is just some math trying to calculate the frequency that we actually want to show in the file. Anyway, that will do some different calculation using a sine wave, because the music that we're creating is a sine wave. It's not a sawtooth. It's not a square wave. We're just doing really simple sine wave. And luckily, Business Central now have the math code unit, so we have the sine function available. But the format of the chunk is actually that this is, and if you have been into audio, you probably know that the music. So we talk about the 44.1 kilohertz resolution of the CD, but that's actually how many samples there are per second. The other thing is the amplitude, and on a CD that's 16 bits. So the music is in 16 bits, and so we run into the same issue as we had in the header, that we in Business Central do not have a 16-bit representation. So right now I'm calculating this to an int. So the actual calculation is in decimals, but then I'm rounding into an int. So somehow we actually now need not to cheat as we just did in the header, but we need to properly turn this into a short. Again, we can kind of use the same principle, because a short is just the 2 first bytes of an integer. So we could actually use another trick of binary of stream. So let's create that procedure. Integer to short, and we have the frequency is an integer, and we want to return 2 bytes. So we have to use them up here, var b2 byte. How about that? So how do we, oh, that's capital F. So how do we actually get, we know that an integer in binary representation are 4 bytes, but how can we get access to those 4 bytes? Well, we could actually, I should add some colons. Everything works better with colons. There we go. We can actually use streams again. So let's just create a temp blob code unit here, and we need to get data. Oh wow, look at that. We need to get data in and out, so we know we need an in stream, and we know we need an out stream. So the first thing we want to do is create the out stream, because we want to put data into the blob. Isn't it lovely? Go watch the video called In, Out, Read, Write, Confusing Directions. You can find it down below just after you subscribed. So let's take the outstream and write our frequency into that. So now we have written 4 bytes into the memory stream. I call it memory stream because that's what it is behind the scene. That's a .NET construct, the temp blob. So now I create a in stream because I want to read again, and what I want to read is very simple. I want to, oops, not increment string. I want to read a byte, and then I want to read another byte, and then I'm just going to leave the last 2 bytes in there because those are just zeros and I don't need them. And as soon as this function returns the code unit is out of scope and removed from memory anyway. So this is a hack. So what we're doing here, write 4 bytes in, read 1 byte out, and read 1 byte out. So we're kind of slicing and dicing. If this happens to be, if we needed the last 2, we would just read the first 2 out and throw them away and then read the 2 we need. So how are we on time? I think we're ready to see if this works. Is there anything else in this program I should have mentioned that I forgot to mention? I don't think there is. So here goes nothing. F5 for compile. Publish. We get Business Central. And by the way, what I didn't show you guys, that's so at the hello world I just said call the generate on when we're opening the customer list. So to trigger this thing. So I sign in. And this is not the fastest ever wave file generator made because this is really not what we want. Anyway, you see we got a download here. So I'll open that. We get a player. And we got music. Let's just hear that again while I check that it's actually getting into the video. So, and just to show you guys at the end that this was not a trick and I took a pre-made something, we could change this to be a longer note. Or let's do 6 6 6 6. See how that. So now we're changing the length of the music of some of the individual notes. So we should probably get a different rhythm. We're generating again. So I think this file is about 600 kilobytes in total size. And we are almost there. There we go. Downloading. Very different rhythms, almost like a swing-based rhythm. So that's one example of how to create a binary, working with binary streams and creating binary data from Business Central. I know that there's probably very few practical applications for generating wave files from Business Central. I thought it was fun, well, if you like fun, if you like Business Central and you like the combination, there's much more coming in other videos, so please subscribe and I will see you in the next video. Have a nice day.